are coming live from Guadalajara, Mexico, as we prepare to start the Mexico Independence Celebration. Say hi. Say hi, everybody. Today is our first Tech Talk with an in-studio audience. And I feel, like I'm about to give a TED Talk. But no, this is a Nextiva Tech Talk, which are public technical discussions where we talk about software development practices and sometimes about artificial intelligence as well. Today, we will hear from Phil Steitz as he covers the principles for approachable software and how you as a developer can make your software more inviting, inclusive, and safe. Again, we will have time to go over questions. Send them to the chat, or here you can raise your hand. With no further ado, please help me with a round of applause to welcome Phil Steitz.
Oh, thank you. Thank you for the wonderful introduction, Ruth, and thank you everyone for taking some time to think about this. And I'll say from the beginning, this talk is really more to inspire than to instruct. There is no single recipe. It's not like do these 5 things and everyone will have a wonderful time with their code. But there are some things that over the years working with lots of different kinds of software that I have learned in terms of how you can make the software that you're working on a little bit easier for the next person. And really it's, I could begin and end the talk with the simple statement that we need never to blame the last person, but always hold ourselves accountable for the next person. If we think about our software that way, everyone is going to have a better time with it. So that's what this talk is about. So I took a stab at defining, what the heck do I mean when I say software is approachable? Well, it means, if I can get the clicker to work, software is approachable if people new to it can quickly learn it, confidently make changes to it, explain it to others, and learn from it. That's kind of a tall order when you think about it. I'm sure you've all had the experience of getting involved in code that you didn't yourself write, because that's what we mostly do in our careers. And if you think about it, the code, if code has these qualities, it's fun. It's going to be inviting. It's like, the idea of, welcoming someone into your house. Really approachable software is like that. You get a nice welcome from it, as opposed to it blowing up when you try to build it or something like that. It's inclusive. Inclusive means, sure, you have to know the programming language. You have to know probably something about the domain, but you want it to be as little as possible, honestly. You don't want to force people to know all kinds of stuff, some special handshake, years and years of specialized knowledge to be able to get into the code. You want to cast a broad net and have a low barrier to entry. This is something that we learned really continuously in the open source world. One of the reasons, a lot of my examples are from open source, where if a project is not inviting, if the barrier to entry is too high, it dies. The community goes away. So if we can think about having that low bar to entry, that's a good thing. It's safe. Approachable software is software that you can, when I say you can confidently make changes to it, you don't want to have a small change cause things to blow up. You don't want to have fear of code. We don't want to be afraid of our software. That's what I mean by safe. It's a safe place. We talk about safe team environments all the time. Code is like that. Really nice code is safe. It's got all these unit tests. I make a small change. I run the test. I know I'm okay. I can understand what it does. And then, finally, it's empowering. I think I've managed to get the presentation out of presentation mode, but Ruth will help me. It's empowering in the sense that because you can understand it, because you can make those changes to it confidently, and you can learn from it, you come out after working with it stronger. you have a feeling that, wow, look at all this new things that I can do, because this code has so much potential, and I can unlock that potential. And also I can leverage what I have learned from the code. So that's the vision. That's, so the question is how do you do it? We will talk about that. But I also want to, before that, I want to talk about why it's so important. Why is it so important? It's important because most of our time as software developers is spent working on code that already exists. So just from that, with my pointy-haired boss hat on, I don't want us wasting time. And also it's just frustrating. You don't want to spend a lot of time getting up to speed. So it's necessary for us to be able to work with. Individuals and whole teams change all the time. We're constantly moving people around. And we like that. We want that. I've been in environments before where, there's one or two special people that know how to do something, and they end up stuck. Because if they're the only ones that understand that code, they might want to go off and do other stuff. And it's better for them to go and do other stuff. It's so much better if we can take individuals and whole teams and just move around. But in order for that to work, the software has got to be approachable. Productivity and quality both suffer. If the software is not approachable, you can't understand it, well, you make those changes and things break. Bad things happen. Bad things happen in production. Also, bad things happen in productivity, because it just takes so long to get things actually to work. Okay, so this is all just kind of why it's important. Now, and then finally, approachable software does teach engineers really useful things. I can't emphasize enough. One of the things that we don't think about a lot is, what are people learning from our code? Every line, it's kind of an aspirational statement, but if you think every line of code that you write is an instruction for the next person who's looking at that code, is saying, hey, this is the way to do that thing, whatever it is that you're doing. If you think that way, you're helping that next person. And if you are that next person, you are thanking the person that came before, because, wow, I just learned something from that code. Okay, there's lots of challenges, and this is not easy at all. If I just stop the talk here and say, okay, go do it, what you would say is, first of all, nobody cares about that stuff. You're just, all the pressure on engineers is to ship. You need to ship the code tomorrow. You need to get, the stuff out into production. You need to hit your deadlines. So we're not immediately rewarding people for these qualities of the software. It's not always possible to achieve it all at once. You can start with a great big hairball that looks impenetrable. It looks impossible. It looks like there's nothing that you can do, but you have to go step by step. You have to be patient, and you have to have that objective that I'm going to make that software more approachable. The next person is going to have an easier time. If you start working on a system or a set of code that has real approachability problems, even if you just make it slightly better, even if you just make a little bit easier time for the next person, you've done them a tremendous favor. You've done their team a tremendous favor, and you've done your company a tremendous favor. It requires persistence and courage, because, as I said, it's not something that regularly people are rewarded for. But at the end of the day, if you really, really focus on it, it builds durable strength. It builds durable strength in the assets, the code itself, becoming easier for people to work with. It builds durable strength in teams and in individuals. So this is all why it's important, why we should focus on doing this. Okay, I'm now going to go into a zoo of practices. As I said, these are not meant to be a recipe, and the examples I chose super simplified examples because I want to get through the talk quickly, but hopefully you'll see how the example illustrates the concept, and you'll walk away with some ideas that are useful. Okay, number one, the simplest and the first, this is the front door. The front door to your house is the build. Maintain a simple working build. You want it to be easy to understand. You want it to be fully automated. The third one is my favorite. It's really hard to achieve. It's it's my favorite because I always scream about it. Everybody here has heard me complain about it because it's hard. When I say it can be run locally with no or minimal special tools or connections, that's a tall order. That means, no, you don't have to have 8 special Oracle databases running. No, you don't have to have connection to some live, mainframe system up. No, you don't have to have a connection into our beloved BroadSoft system. You want to make your builds ideally so you can just run it locally. And this is something that the whole concept of doing that really did start in the open source world, because in open source, people don't have all those things. They don't have the special tools. They don't have the special connectivity. You want to just be able to check out the code, run, build, bang. And that is tremendously productive. And for the same reason that it's tremendously productive and valuable in open source, is tremendously productive and valuable in any software development environment. Obviously, the build, you don't want the build to just, blow chunks and some funny stack trace. Oh, sorry, it blew up. If the build breaks, tell whoever's running the build something that is enlightening. Now, again, this is not easy to do, and I will say the only time I've ever really fully always had it was in open source projects. But in any case, this is principle number 1. It needs to be fast. Okay, quick example. This goes a trip down memory lane for me. This is when I first got involved in open source, was Apache Struts was the first open source project I worked on. And initially, the build was, new Struts developer would take like a week to learn how to build software. You had to put the special jars in the special thing. The jars all had funny names. We didn't have version numbers in the jars. It was just a mess. It would take forever. That's why we invented Maven. Honestly, that's where it came from. Maven came from within the Turbine project, which was another Apache project. And now you just check out the code, and you people here are mostly kind of spoiled by this. The Maven lets you do declarative builds, and it's just incredibly powerful, because you can declaratively specify what has to happen in the build, and it will just happen. Okay, that's a simple example. Maintain a working build. Next one, clearly document contracts. When you step into some code, it's like you've got a new job. The next person has got to know exactly what you've committed them to. We've all had the experience of working with new code, get involved in some code. It now belongs to you, and you don't even know what it's supposed to do. You look at some documentation, but it could fail in funny ways. You don't really know what you've been committed to. You need that to be documented. That's the thing that you need to lead to the next person. Ideally, you have unit tests. The nice virtuous cycle is you've got nice Java doc or external documentation that says what the system needs to do, and then you have test it, verify it. And then there you go, that's safe. Think about how safe that is versus it's unclear what this thing is supposed to do. It's not documented anywhere. I'm gonna make a change. It blows up, I get yelled at. That's not safe. And you don't want that. So you also wanna maintain that. You wanna, as you make changes, often the documentation and tests kind of drift, and you'll have things that leak in, and then your thing is not approachable. So an example of this, quick example. This is super simple example. This was from all versions of Apache Commons pool up to like 2.4. It's got a method where you can add something to the pool. Okay, it's an object pool. It maintains instances that you check out. Pretty much all of the connection pools, the Mongo and Redis and every Java connection pool uses it under the covers. And so it maintains instances. Okay, so it has a method that says, let's shove some new stuff in. Fine. And it tells you that that will be useful for preloading pools. Fine. But a question that you might have, and that I actually had when I started working on this thing was, well, what's supposed to happen when you want to add an object, but there's no capacity to add it? Like the pool, you're up to the maximum number of objects already in circulation. What are you supposed to do? What does it do? Well, I look at the code and I realize that in fact, first of all, there's 3 things that it could do. It could do nothing. It could raise an exception, or it could block. Any one of those would be sort of legit behaviors here. It's not documented, you don't know what it does. So real super simple thing, you just add a statement that tells what it does. And then it's clear. It's clear to every maintainer of this software, anyone who's going to work on it, anyone who's going to use it, that if there's no capacity, the thing's a no-op. It's not going to do anything. And you don't have to think about it. And you don't have to worry about it. Again, these are meant to be super trivial examples, but the basic idea is you need to make the contracts explicit somehow, so that when somebody is making modifications to code, somebody is using it, they know what it's supposed to do. It's like having job requirements when you get a new job. Okay, next one, take out the trash. Broken shit is not okay. Another barrier to approachability is all kinds of garbage in the code that doesn't work. Oh, everybody knows that method is broken, don't use it. Everybody knows that, well, who's that? The newbie is not everybody. The new person coming in doesn't know about what's broken. They don't, unless somebody tells them, unless you sit down and explain to them in detail, don't do this, do that, they don't know. It's way better if it's just not in there. Unless you remove the broken things, you can't be sure if they're still being used. And that's actually one of the hardest things about taking out the trash. There'd be a whole lot less trash in code if you didn't have to go do the work of figuring out where the trash is still being used. You have to do it. Otherwise, it just lingers, and it's not approachable. It's not safe. Whoa. I think I did a few too. Well, okay, here we go. Take out the trash. There's an example in here somewhere. This thing is responding funny. Okay, so this is an example that hit me personally. I was newbie way back when I was a pup. Okay, you got a financial services account management application. It has a close account method that in some module that takes an account ID and a cancel code. So you want to cancel an account, you provide both of those. It also has a version that uses a default cancel code. So you don't provide the cancel code and it just does it. Initially, they both work. Second one applies default, everything's cool. Eventually, time passes and the second one gets deprecated, but not removed and not even clearly marked deprecated. It's still there, but it doesn't work. And not only does it not work, it actually throws a null pointer exception when you call it. Newbie calls the thing and it blows up. And that's just painful. That's not, again, it's not safe, it's dumb, but I can't tell you how much of it I have seen and how important it is to as you maintain code, make sure that people know actually what is broken. Okay, and get rid of it. The next one is another one of my favorites, which is do the obvious thing. Well, obvious to who, but it's, and we'll get the example, you'll get a kick out of the example because it is somewhat relative, but still the idea, the next person should be able to write the code that they're about to see. That's again, it's a tall order, it's aspirational, but I've seen code like that. I actually have, I've enjoyed looking at code that you can actually see what's going to happen and go write it yourself and see, oh, that's in fact what they did. That's a beautiful thing. And it gives you, that's that sense of empowerment too, because that means like you're part of it. You're part of that code because it's acting normally, naturally, the way that you would expect. If there's a standard algorithm, use it. That's what I mean by the obvious thing. Favor stock data structures and language. Don't invent your own map. Don't use parallel arrays for where you could use, these are, if you do funny stuff, people scratch their heads. Why are they doing that funny stuff? And that's that cognitive load. That's that they get a little bit scared of it because they're wondering, why is this code so strange? We don't want them to wonder why it's so strange. We want it to be the natural thing. Okay. Follow conventions and leverage abstractions. So I almost pulled out separately, be consistent, because it's super important. And that's really essentially what this is saying. Be like yourself. Write code that once people get to know the style, that it is consistent and it is essentially as predictable as it can be. Okay, this is a funny example where you've got two maps and they're keyed on topic IDs and the values are the amount of time that people have been looking at content. One holds sports content and the other holds business content, and there's some overlap between the two maps. So there's some things that occur in both. And what you want to do is you want to create a single map that has all of those entries in it, and has, for the ones that are common, you just want to sum them. Okay, so think about how you would do that. There's natural, easy ways to do it that don't require that you think very much, or you could be like super devious clever and do this map comprehension, extract the key sets as streams and then use a collector. This is beautiful in some sense. It's really nice code, super compact, but you have to think about it. The cognitive load of thinking about this code is actually not worth, and especially in Java where everything's optimized, if you just did the natural thing and extracted the key sets and iterated and did the way you would think about it, then the person doesn't have to waste time scratching their head and saying, well, wait a minute, how does that work? The collectors and the integer, the sum function. Now, I know some people, this is where I said it, do the obvious thing, it's relative. Some of you will say, oh, this is functional programming, dude. Like, wake up, this is a new world. This is how it's supposed to be. But I don't care if you're John McCarthy, you don't think like this. Okay. So, but it maybe not the best example, but the basic idea is important. Do something simple. The next one is perform completed actions. One of the things that's really challenging is you want people to be able to execute software systems in their head. That's the best way to really be invited in and understand fully is you're actually running the code in your head. And you're running often across component boundaries and you're executing lots and lots of calls. If it takes a whole sequence of calls that do half completed action to get something done, you're forcing a person to hold all that in their head, to learn it and hold it all in their head. If you can make it so that you're actually performing completed action in the individual methods or functions or whatever they're called in your programming language, that's going to be a lot easier for the person. It's easier to comprehend. Don't pass around half-formed data structures where a data structure, has a structure to it, and you have to remember, you have to have the insider knowledge that, oh no, those are all null until I get to, stage 7. That kind of thing makes it risky because people might make assumptions and those assumptions aren't true. And it also just, again, makes them think more. It makes it harder to execute the code and to understand what it's doing. Also, you want to make if there are sequencing and atomicity requirements, you need to make them explicit. People need to understand what they are. Okay. You want to keep partial actions private. So here's a simple example. Again, from a commercial environment where you've got a hotel reservation system. There's a method, process reservation, fine. It takes some data, and you would expect that thing looks like it should process a reservation. JavaDoc says that's what it does. So you call it, you expect, okay, done. Oh, I found the method that processes a reservation. And then you call that method. And then you gleefully think, check, I'm going to, mark my issue as done and move along. And then you realize that, oh, wait a minute. This thing actually just initiates the payment and sends confirmation. But you always have to call update inventory and publish inventory change afterward. This is the secret handshake. If you don't know the secret handshake, then you just ended up billing somebody, but not actually getting them a reservation. And most importantly, not telling the great world of online travel agencies that inventory change happened, which is the cardinal sin of hospitality tech. Okay, so the idea, the answer here is really simple. The person now has to learn all that stuff. It's a secret handshake. You don't want that. So you make a single public method, and you have it, do the other things, but it's not good enough just to make a single public method. You also have to go and clean up the trash where all those little sequences of half-done things were. You have to actually refactor so that the thing makes sense. The logic is evident. It's doing what it's supposed to do. Okay, next. Choose and maintain names thoughtfully. This is something a lot of people think, oh, it's stupid. You can call everything bird, berg, bid, and vowels, just anything you want. That isn't. It actually makes a difference because first, thinking is harder than typing, and all the IDEs now will type for you. So don't complain about variable names and method names that are a little bit longer. And when meaning changes, you can't just keep the old names around. And it's hard, you have to deprecate and replace and all that kind of stuff. But having things named, the next person thinks the name means what it says. Again, it's thinking about that next person. They come into the code, they see something that has a name, they expect that's what it is. And if it's not that, then you're making it harder for them. It's simple. It's more likely they're gonna make mistakes, and it's also more likely they're not gonna find what they're looking for. Here's a trivial example, a pet peeve of mine. It still exists. Again, in Commons Pool, another one, the same open source project. It has this thing that we call a victor. That what it does is it eliminates objects that have been idle too long. It eliminates things that it has deemed abandoned. It eliminates things that fail validation, but it also does other stuff. So it was named the evictor because of that eviction action. But initially, that's all it did. But then now it's the general maintenance thread. And so suppose I want to find out, how does this thing add enough idle objects to ensure min idle? How does it do that? Well, turns out that it's in there. Why would you think to look there? It takes forever. You're scratching your head. That's dumb. Okay. And the next one is another sort of obvious one, but one that you have to think about. Use only the technologies that you actually need. You remember that the next person may not know the superfoo framework that you like. That's your thing that you really have been looking for an opportunity to use. That is not inclusive. If you demand all kinds of specialized knowledge, dependencies, well, they're dependencies, and reasoning about code that has excessive framework bloat in it is harder. It's much harder. The stack traces are way more complicated. That executing the system in your head is harder if there's a lot of gratuitous abstraction and extra layers and layers of stuff. That actually makes code less approachable. So this is a kind of ridiculous example. You've got to receive readings from IoT devices, maybe they're lawn sprinklers, whatever. There's a few hundred of them, and you want to maintain statistics. That's the task. That's what you need to do. Well, if you want to be like super cool, you bring in Spark streaming and RDDs, and I love that stuff. I mean, it's Apache project. I love Spark. It's cool, but forcing my team to learn that for that application? Are you kidding me? This is it's a slightly modified, but this actually happened, and it does happen. It's fine to want to use new technologies and learn them, but you can take my word. You can take the promise that you will have plenty of opportunities to have genuine need for advanced technologies in the applications you work with. Use them there, as opposed to making increasing the barrier of entry to your software. Okay, understand and document all failure modes. The next person doesn't know about failure scenarios, and that aren't documented. And that's another, you step on the landmine. It wasn't specified anywhere that something bad could happen, and it happens to you, and that's just a terrible thing. It's not safe. Some of the assumptions that you made when you wrote the code may not be true anymore, as it evolves, and things that just silently fail, which is a place where this really can bite. Silent failures are really, really bad, especially for newbie. The new person, if your code is failing silently, a newbie doesn't know about that failure mode, it's a bad thing. This actually happened to one of my teams, and this was back in financial services. You have a real-time transaction processing system. It looks up transaction codes and processes them accordingly. Okay, fine. What happens when it gets a transaction whose code doesn't exist? So it's, what does it do? And again, it's one of these specify the behavior. Well, it's not specified. And it does a silent failure, but that's actually okay because there's a background process that reconciles and posts failures to a log. So, you know, it was set up, it's okay. The problem is nobody told newbie about the silent failures or the log. It filled up, and you know, come on, it's unfair. This poor person they're now getting yelled at and screamed at because they're not paying attention to the log that they don't even know exists because it's not documented anywhere, and the thing is failing. So that's a trivial example. Okay, I have two more, and I'll just get through. Don't fight with the code. Another one of my favorites. We go into these battles, you know, continued hacking and hammering makes code less approachable. That's just how it is. If you get to a point, and you know, many of us have been there before, where it gets to the point where, you know, it's just too hard, and the next person is going to inherit your battles, but not your defenses. The next person is going to come out onto that battlefield. They're not going to know where the enemy is. They're not going to know the special tricks that you do to kind of be able to make changes to it. So at some point, somebody's got to have the courage to end the conflict, to say, okay, we are going to refactor. We're going to do something different. We're going to actually go after this and slay the dragon and stop fighting with our code. Okay, beautiful example here, maybe familiar to some, monolithic travel and expense application that was written by a startup team and then handed over. And then it was just, you know, mangled to do all kinds of other stuff. And it got to the point where it was so hard to build, so hard to do anything with, that it literally almost imploded on itself. And somebody had to get the courage to decide, okay, we're actually the first attempt was to just wrap microservices around things. And that sort of provided a little bit of relief, but it didn't actually slay that dragon. It took courage beyond mine to get it actually done. So, okay, don't fight with the code. Last one, talk about the code. This is it's a beautiful thing because it's actually fun. Your own understanding is improved. I can't tell you how many times I've worked with people working on coding problems, and they come to me for help, and simply explaining to me how they think the code works, then they go away and, oh, I figured it out. You've all done it. You've all been there, where like, oh, halfway through they halfway through the explanation, they realize what their problem is. So just talk about it, and you know, your own understanding gets improved, but the next person might be in the audience, the person that's going to get it next. And this is something I have to ask, you know, to this team, you know, constantly talk to others about the code that you're working on. And because the idea that we can move people around, people can work on different stuff, that's all good. It's very good for us. And it also does really enhance our understanding. And if the code is inscrutable, that will also become clear when you try to explain it. That's my acid test, is I try to, you know, go do a code walkthrough mentally on some code. If it's really, really, really hard to explain, then that means there's some work to be done, and that motivates me to go after that work, or others who are listening and who are talking to me about it. This is one of the reasons in open source that, you know, we do all this discussion of the code. Okay, simple example, sort of close to home here, where we have a massive complex set of NLP frameworks and technologies that are being wired together to deliver capabilities that we want to bring to market. And it's really hard because there's so much of it, and it's also variegated. So the answer there is we spend time. Make sure that it isn't just the daily stand-up, that you have extended stand-ups. You do things like paper talks, you do things like tech talks, you do presentations. This is something we do Dev in Bites within Nextiva. Part of the value of the Dev in Bites is really to get that shared understanding of the core stuff that we're working on. Okay, so that's really all of the practices. If we do all these things, things are going to be good. Well, at least better. One, maintain a working build, clearly document contracts, take out the trash, do the obvious thing, perform completed actions, choose and maintain names thoughtfully, use only the technologies that you need, understand and document all failure modes, don't fight with the code, and talk about the code. Do all those things. And like I said, it's not a recipe. There are other things that are important too. But if I can leave you with one idea, it's really just to think about the assets that you and your team are working on today need to be a welcoming and fun place for other people. Think about it. If you sort of think about it as your house, that's a different way of thinking. And it's a painful way, because often our house isn't that nice. You know, it's almost never really like you'd want your actual physical house to be. But if you think about it that way and think about, I want to create this fun and welcoming place. It's what we work on every day. Then good things are going to happen. And always think about getting the right ideas into the mind of the next person or a new person joining the team as they jump into the code. Think about their sort of onboarding, their cognitive onboarding into your code. If you think about that, then you're going to do things just a little bit differently. Approachability doesn't require any special SDLC. I'm not telling you, no, you use this magical method. It's actually more a mindset. The principles, the practices that I laid out aren't recipes. They're not, sort of checklist things. They're really more just illustrations of a mindset. And I bet if you think about it and start doing more of this, you can come up with 10 more that are things that really just illustrate the right way of thinking. Okay, that is pretty much all that I wanted to present. And now, happy to take any questions, comments anybody has.
All right. Any questions from the audience, maybe? No? Come on. Yes, Nacho.
So just regarding the role of refactoring and all of these, how do you ensure if the environment that you're working on is not safe, as you were describing regarding the test, and you are not certain regarding other integrations in the project that you're working on?
So you're sort of asking, how do you bootstrap the whole thing? If you
kind of the thing is already bootstrap and you are going to do some changes, but you are not sure which parts are trash, which are not, and you are going to discover that.
You're looking at taking out the trash.
Yeah.
Yeah. Well, I mean, there's no kind of magical recipe there. It's and you don't have to say, okay, today I'm going to take out all the trash. That likely won't happen. On the other hand, it's more a habit of observing the trash, as you see it, and then identifying what can be done about it. Now, if you're starting in a system that doesn't have really great documentation and doesn't have really great, unit tests and that you have all kinds of complex interfaces, yeah, you have to be careful. And that's part of the reason that it might be littered with trash itself, that people deemed it as unsafe. You first have to get that conceptual control of what exists. And what I tend to always recommend is you start with tests, add tests, either unit tests or integration tests that confirm your hypothesis about, what may be trash and what can be done about it. But that's, there's no, single magical formula, but hard analysis of the code, talking to people that have good experience with it, and developing instrumentation and testing.
Any more questions from the audience? Anybody? Ay, me haces correr.
Hi, Phil, again. So how do you recommend to deal with these good practices and also to the like urgency with the projects?
You know, that was, you know, at the very beginning when I said you're not immediately rewarded for it, it's a genuinely hard problem. And what you have to do is you can't necessarily try to do it all at once. You can develop very approachable software very quickly with the mindset, if you think about it. So think about your, you know, as you're developing new code or as you're making changes, the amount of time that it may take just to add a little documentation or add a unit test is small. It's not large. And you shouldn't think of it as a sort of an either or. Either I produce this beautiful approachable code or I just crank and hit deadlines. You got to find the middle ground between those two. You have to, sure, in some cases it takes longer, but in other cases, actually it doesn't, because you're thinking about the approachability and the structure of the code can actually make the amount of time it takes you to develop it less. It's very similar to unit tests, very similar to unit tests. If you think, I don't have time to write unit tests, and you just crank forward the code, then you scratch your head and scratch your head and scratch your head and wish you had written unit tests. And so, you know, you definitely hit on the hardest problem. The hardest problem is you're not directly rewarded for it. It doesn't help you hit your deadline. But at the same, but you are rewarded for it with a better experience when you come back to it or when you help new people get into it.
We have a question from our team joining remotely. As a general rule, we don't comment or our code. Do you think we should?
Okay. I'm reminded of that famous Dos Equis commercial of I rarely test my code, but when I do it in production. Yeah, that's a painful statement, and that's a very painful statement. And in fact, now what my view is that that any non-trivial method needs to have a method documentation. You really should be there, and it should be correct. And if you're not putting any documentation at all, then, you know, the only way that a person can approach that code is by reading the code fully. And then, you know, maybe there's some unit tests, but having some basic method documentation, it doesn't take that much time. And honestly, it helps you when you're writing the code, because it says, you know, you're writing all that stuff into Jira tickets anyway, or somebody is. You know, you're writing all that stuff somewhere. And if you just take, it doesn't have to be a book. And in fact, it's better if it's not a book, because we don't read books. Nobody reads books anymore. Some people do.
Finished books.
Right. Some people do. I know some people who do. But yeah, that's a painful statement.
Okay, another question that we have is, how do you choose the right technology for a specific problem or project? Do you prefer some programming languages for specific contexts like big data, API development, machine learning? So how do you choose the right?
There isn't a real, you know, single generic answer to that. You know, I will say that the principle that I stated of using appropriate technology, only bringing in things that you actually need, I do believe in minimizing complexity. That, you know, if I had to say what's the principle, it would be minimize complexity.
Any more questions? Here. There you go.
Hey, regarding we balance the junior senior, because some junior doesn't have all the information of how to test, how to write like more concise methods and having like centralized. What is your thought regarding allowing some errors or declining the pull request until they get the like everything involved in that? How should we teach them?
By example. and by a careful review of the pull requests. You know, there's no, you know, I think you definitely, it's especially the setting the right example for people that are coming into a team and or that are developing their career is super, super important. You want to do it gently. You don't want to, like, you know, it can be demoralizing. When I made 7 attempts at a PR to, you know, change a variable name, and, you know, and I'm getting frustrated. So you don't want it to be, again, you want your team and your process to be inviting and people to, you know, have positive mindset, but you got to teach them how to do it. That's your job, you know, as a senior person, is to get those right habits in. And then it really, once the habits are in, they just happen. People will just continue to, you get the good habits early in someone's career, that's how they are. So I would err on the side of gentle encouragement to do things right. And also the other thing is, don't just fix it and, you know, not tell them.
We have another question in the audience. Oh, Mr.
So my question is, approachable software, how is applied to legacy systems? Is a modernization or a factoring? Because you can bring existing users of the legacy system to a new system or refactor the legacy system. So how this approachable software applies to legacy systems?
That's a hard question. And it, you know, the answer is it sort of depends on the legacy system and how much you're willing to invest in it, how much you're going to change it. If you are going to change it, if you're going to evolve it, if people are going to have it be their house, then you got to chip away. You know, you got to get it to be approachable. If it's not going to be changed very much, if you can encapsulate it with APIs that sort of, you know, hide the ugliness, then yeah, then that's fine. That's, you know, then you're not thinking about it. But a lot of it does depend on the value of approachability. It you know, varies directly with how often you have to approach it and how many new people are going to come in and have to understand it. If it's just sitting there and it hardly ever changes, then the investment is not worth as much.
We have another one. This is a long one. Refactoring or cleaning up problematic code bases can often be extremely time consuming if the technical debt has been built up over many months, years, and the code base in question lacks effective test coverage. How do you think engineers should approach advocating for this type of work over the endless slew of feature requests, especially since new features are almost always more impressive to leadership compared against a lengthy refactor that has no surface level difference? As engineers, we can feel that a code base is drastically easier to update, maintain after a refactor, but you can't really showcase that in a sprint demo or assign some sort of measurable improvement before, after the refactor.
Oh, man, I'm really getting the softballs here. That's you know, this is great because we're having the right discussion here. These are the hard problems. These are really the hard problems. And I would be, you know, completely bullshitting if I said that there, you know, I have the magical solution. What I can say is that while, and I've been a leader for a long time, so I'm involved in these discussions, and the one, while you can't show in a sprint demo, what you can show is the amount of time that it takes to make changes, the amount of time that it takes to actually get things to work. So if you've got something that really does need to be taken out and shot and you want to end the battle, if you look at, you know, you say, look, we spent the last 4 months and we got like 5 trivial features out, then the leader who you need to get to agree to invest either has to think you're, you know, bumbling idiots, which you're not, or they will start understanding that, oh, I get it. they're banging their head around this stuff. Then you can't, if you present, I want to completely replace this thing, do this big refactoring, it's going to take 2 years. That's just never going to work, because you're going to need to, you're going to need delivering. So the refactoring plan itself has got to deliver incremental value, and you've got to celebrate the wins when hey, guess what? I could now do this thing way faster than the same kind of thing that I did before. So almost like, the way we point work in sprints, if you can actually point, pre and post refactoring and demonstrate that, then you can get more support. But this is super hard. It's not there, and sometimes it's almost impossible to fully do, because there's so much software value in the hairball.
All right, another one. How do you encourage updating documents to prevent tribal knowledge? From my experience, once documents are written, they're rarely updated, as teams do not consider the time taken to update the documents as part of tasks.
For the two answers to that, number one, you have to consider the time to update as part of the task. Number two, and this is where, I call me a weirdo, but I like as much as possible to have that documentation in the code and in the tests. So it's not maintaining external documentation is important sort of at the architecture level. It's important at the sort of product functionality level, but in the code, if the code is carrying its documentation inside it, and it's also approachable to the point where you can understand it, you don't have to write a whole lot of extra documentation, that's better.
Awesome. Any closing statements, Phil?
Just taking great questions, and again, I'll end with the same thing I said at the beginning. Let's not, the last person isn't going to come back and fix things. But blaming the last person doesn't make any sense. You don't know what they were dealing with. You don't know what pressures they were under. You don't know what led to the craziness that's in the code that you have that's sitting in front of you. But you can improve the experience of the next person. You really can. And if you hold yourself accountable for that experience, for what it's like for the next person who's working with the code that you're working on right now today, then that's good. It's good for them. It's good for you, because your understanding is going to be enriched. It's good for their team. And if that was my sort of one message here, to try to stimulate that thought. Simple. And it is something that I have seen. You can get into a virtuous cycle where that mindset, kind of takes root, and the software gets better, and it becomes easier to work.